this video we are going to discuss about homogeneous equation. So standard form of first order ordinary differential looks like dy dx equals f of xy. So equation 1 is said to be homogeneous if for every real number t, f of tx ty equals f of xy. Or f of xy can be written as x to the power n times phi of y upon x. We have to note that a homogeneous equation can be transformed into separable equation by substituting y equals to vx with dy dx equals v plus x dv dx. So try to understand this by an example. So here is an example. So if we compare this with dy dx equals f of xy, so in this case f of xy is nothing but y plus x upon x. So take any real number t. So tx ty, which is nothing but ty plus tx upon tx, or t times x plus y upon tx, and tx gets cancelled, we'll get y plus x upon x, which is nothing but f of xy. That means the given equation is homogeneous. Homogeneous equation. So substitute y equals bx. So b is a function of x, so that we can get dy dx equals b, derivative of x with respect to x is 1, and x times derivative of b is dv dx. Put these values in equation 1, then we will get equation 1 becomes v plus x dv dx equals bx plus x upon x. Or we can write this as v plus x dv dx equals v plus 1. Or v gets cancelled, we can write this as dv equals 1 upon x dx on integration. What we will get dv 1 upon x dx, and we have to introduce an integrating constant c, integrating constant, or b, and integration 1 upon x dx is nothing but log x plus c, and we have to substitute the value of b from here. So b is nothing but y upon x. So we have to put y upon x equals log x plus c, or y is nothing but x log x plus cx, which is the solution of equation 1. Now try to solve another question. So we can write equation 1 as dy dx equals negative y times x plus y upon x square. Now see, this is homogeneous equation, because if this is our f of xy, then for any t in R, f of tx ty, which is equals negative ty tx ty upon t square x square and negative t square y times x plus y upon t square x square. So t square gets cancelled and we'll get f of xy. That means this is a homogeneous equation. And we can easily tell that equation 1 is a homogeneous equation by observation. What are the things to observe? That the power in the denominator, that is x square, is 2, and in the numerator we have two terms. One is xy and another is y square. So power of y is 2 and xy, power of x is 1 times, there is a product, so we have to add them, add the powers. That means power of x is 1 and y is 1, 2. So all the terms in the numerators are of power 2 and also in denominators 2. So we can, by observation, we can see that this is a homogeneous equation, or we have the formula that f of tx ty equals f of xy. We can do by observation, but we have to write this formula in the sum. So it is a homogeneous equation. So we can substitute y equals bx. So from here we will get dy dx equals b plus x dv dx. Put this value in equation 1, we will get v plus x dv dx on the left hand side, and on the right hand side we will get negative y, that means bx, and bx plus x upon x square. Let's see. Okay, right. So from here we'll get negative b times b plus 1, or we can write this as x dv dx equals negative b times b plus 2, because on the right hand side we have negative b square, negative b, and from left hand side negative b. So we have negative b square, negative 2b. So negative, we take common negative v, so we will get v plus 2. Okay, so now we can write this equation as a separable equation easily, and that can be done as a dv upon v times v plus 2 negative 1 upon x dx, or we can write this 1 upon b times b plus 2 as 1 upon b negative 1 upon b plus 2 times half, because if we calculate this we will get v times b plus 2, and on the numerator b plus 2 negative b, v cancelled, so 2 times these things, but we have 1 upon b plus b times b plus 2, so we have to multiply by half. So this can be written as half times 1 upon b negative 1 upon b plus 2 dv plus 1 upon x dx equals 0. Okay, so integrating we will get, or we can multiply this half here, so we'll get log v from the first thing, because integration of 1 upon v is log v, negative log v plus 2 times log x equals, let's say, log c, where log c is a integrating constant, or we will write this by logarithm formula. This is nothing but v upon v plus 2 plus log x square equals log c, or log v x square upon v plus 2 equals log c, or we can write as vx square upon v plus 2 equals c. So if we put the value of v, that is, we have y equals to vx, or v is nothing but y upon x. So put the value of v, that is y upon x. So y upon x times x square upon y upon x plus 2 equals c, or we will get xy equals c times y upon x plus 2, or xy equals c times y plus 2x, or we will get x square y equals c times 2x plus y. And this is the solution of the equation 1.